March 12th, 1944. Schweinfurt, Germany. Oberleutnant Franz Stigler stands next to his Messerschmitt Bf 109. The engine is cold. It's been cold for 3 days. The mechanics are waiting for parts. A single fuel pump, 2 spark plugs. They're somewhere between Munich and the airfield if they exist at all. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Every aircraft is a masterpiece. Hand-fitted components, custom-machined parts. Stigler knows this. He was trained at the fighter pilot school at Werneuchen. They told him German engineering was superior, German fighters were superior, and when something broke, it took time to fix. Days, sometimes weeks. This was normal. This was war. Across the English Channel, at Leiston Airfield in Suffolk, an American crew chief has a different problem. His P-51 Mustang took 20mm cannon rounds through the left wing, 3 holes, each the size of a fist. The pilot brought it home anyway, landed at 1700 hours. It's now 2100 hours. 4 hours later, the wing is patched. The aircraft is ready to fly. The German pilot doesn't know this yet. He doesn't know that the Americans have broken the fundamental rules of aircraft maintenance. He doesn't know that while he waits for 2 spark plugs, American mechanics are replacing entire engines in 6 hours. He doesn't know that the war isn't just being fought in the sky. It's being fought on the ground, with wrenches and rivets and 18-year-old mechanics who learned their trade 6 months ago. The morning of January 11th, 1944, over Oschersleben, Germany, the 8th Air Force sends 291 bombers deep into German territory. 60 fighter groups escort them. Most are P-47s and P-38s, but 13 are flying the new bird, the P-51 Mustang, Merlin engine, drop tanks, range of over 1,600 miles. For the first time, American fighters can escort bombers all the way to the target and back. Major James Howard of the 354th Fighter Group encounters 30 German fighters attacking a bomber formation. He's alone, his squadron scattered. For 30 minutes, he engages the entire German force by himself. He shoots down at least 3, damages several more. The bombers get through. Howard receives the Medal of Honor. But the story isn't just about Howard's courage. It's about what happened when he landed. His P-51 had taken hits, 20mm rounds, 7.92 machine gun fire. The cowling was punctured. The tail section riddled, 1 aileron damaged. The ground crew met him on the hardstand. They started work immediately. Howard filed his report. Ate dinner. Slept. 8 hours later, his aircraft was ready. Same plane, same tail number, ready for the morning mission. A captured Luftwaffe pilot at an interrogation center in London hears this story. He doesn't believe it. Impossible, he tells the interrogator. Aircraft repairs take days. Battle damage assessment. Parts requisition. Structural integrity checks. This is not how it works. The interrogator smiles. That's not how it works for you. The difference isn't just speed, it's philosophy. The Luftwaffe builds fighters the way it was taught at technical schools in Munich and Dresden. Each aircraft is unique, parts are hand-fitted. When a fuel pump fails on a Bf 109, the replacement must be precisely matched to that specific engine. The mounting holes won't line up perfectly on any other aircraft. Mechanics must adjust, file, modify. It takes time, it takes skill, it's craftsmanship. The Americans build fighters differently. They build them like cars, Henry Ford's assembly line, applied to war. The P-51 uses standardized parts. Every fuel pump fits every engine, every spark plug fits every cylinder. The bolt that holds the landing gear on aircraft 44-72-483 will fit aircraft 44-74-939. They're identical. Not similar. Identical. Mass production as military doctrine. At North American Aviation's plant in Inglewood, California, They're building P-51s at a rate that would horrify German engineers. The prototype took 102 days from contract to first flight. By 1944, they're producing one complete fighter every 45 minutes. Not 45 minutes per component, 45 minutes per complete aircraft. 14 aircraft per day from a single factory. The entire production run will reach over 15,000 units. The parts numbering system alone is a marvel. Every component has a designation. The prefix identifies the aircraft model. The suffix identifies the functional group. A part ending in 58,000 is hydraulic, regardless of which P-51 variant it's designed for. A mechanic in England can order a part and know exactly what he's getting. No confusion, no special fitting required. The part arrives, it installs, the aircraft flies. February 11th, 1944. The 357th Fighter Group flies its first combat mission over Germany. 24 hours earlier, half these aircraft were still being assembled in California. Now, they're over enemy territory. The pilots have less than 20 hours in type, some have under 10. The mechanics have even less experience, but the aircraft don't care. Standardization makes experience optional. A mechanic with 6 months training can do what used to require years. The crew chief system in the 8th Air Force is ruthlessly efficient. Each aircraft is assigned to a specific crew chief. He has an assistant and 1 to 3 mechanics, depending on the squadron, but they're supported by specialists, armourers, radio technicians, engine mechanics, hydraulic specialists. When an aircraft lands with damage, multiple crews swarm it. They work in parallel. One team fixes the engine, another patches the wing, a third checks the guns, fourth inspects the controls. They don't wait, they don't queue, they attack the problem from all sides simultaneously. Technical Sergeant James McKnight is a crew chief with the 353rd Fighter Group. His aircraft takes flak damage over Frankfurt, hydraulic line severed, landing gear won't retract, right wing panel punctured, the pilot nurses it home, lands at 16:30 hours. McKnight's team goes to work. The hydraulic specialist has the line replaced in 90 minutes. Standard part. AN fitting. No custom work required. The sheet metal team patches the wing with aluminum from stock, pre-cut panels, standard rivets. The landing gear mechanism is checked. No damage to the actuator, just the line. By 2100 hours, the aircraft is ready. In Germany, a similar repair would take 3 days minimum, maybe a week. The Luftwaffe doesn't have unlimited spare parts. Production is scattered. Factories are being bombed. The supply chain is breaking down. When a part fails, mechanics must sometimes fabricate replacements by hand. Machine shop work. Custom fitting. Time-consuming. And while they work, the aircraft sits. The pilot waits. The war continues without them. The numbers tell the story. By mid-1944, the 8th Air Force is flying over 1,000 bomber sorties per day. Each bomber needs fighter escort. The fighters need to be airworthy, mission-ready. The entire operation depends on maintenance. The Americans have 270 P-51 Mustangs operational in the 8th Air Force by March. By December, they have over 1,000, not because they're building them faster, although they are, because they're keeping them flying. The maintenance-to-flight hour ratio is staggering. The P-51 is the easiest fighter to maintain in the European theatre, better than the P-38, which is a maintenance nightmare with its twin engines and turbochargers, better than the P-47, which has reliability issues with its turbo supercharger system. The Mustang's Packard-built Merlin engine is liquid-cooled, which makes it vulnerable to small arms fire. But when it's not damaged, it's reliable. Inspection after 25 hours, 50 hours, 100 hours. Engine change after 500 hours, all scheduled, all predictable. An engine change on a P-51 takes 12 to 16 hours with a full crew. Not days, hours. The mechanics unbolt the cowling panels, quick-release fasteners, no custom fittings, disconnect fuel lines, hydraulic lines, electrical connections, color-coded, standardized. Remove the propeller, unbolt the engine mounts, 4 bolts, standard threads, lift the engine with a hoist, install the replacement, bolt it in, connect everything, 4 bolts again, same threads, same torque specifications, refill fluids, run up test, done. The Luftwaffe doesn't work this way. A Messerschmitt Bf 109 engine change is more complex. The engine is partially built into the airframe. Removing it requires more disassembly, more time, and the replacement engine must be adjusted to fit that specific aircraft. The motor mounts might need shimming, the propeller hub might need timing adjustment. It's precision engineering. It's beautiful. It's slow. March 5th, 1944. The Werneuchen fighter group receives their P-51 Mustangs. They've been flying P-47s, Thunderbolts, heavy, rugged, reliable. Colonel Don Blakesley, the group commander, gets his Mustang on February 20. The next day, the aircraft are ready for operational flying. 4 days later, on March 4th, they escort B-17 and B-24 bombers to Berlin. Less than a week from delivery to combat over the German capital, a Luftwaffe intelligence officer receives reports of this transition. He doesn't believe them. Fighter groups don't convert aircraft types in a week. Pilots need training, months of it. Mechanics need to learn the new systems, also months. Supply chains need to be established, parts inventories built up. This takes time, planning, resources. But the Americans did it anyway, because standardization makes the impossible routine. The P-51 itself is a study in efficiency. North American Aviation designed it in 117 days, from requirement to prototype. The RAF needed a fighter. North Americans said they could build something better than the Curtiss P-40, which the British wanted. They delivered. The prototype flew in October 1940. It was good, but not great. The Allison engine limited high-altitude performance. Then the British tested it with a Merlin engine. The results were transformative. The P-51B, powered by the Packard Merlin, became the war's decisive fighter. The factory at Inglewood ramped up production with unprecedented speed. They didn't have time for custom work. Everything had to be standardized, interchangeable. The wing panels from one aircraft had to fit another. The control surfaces had to be identical. Even small parts, bolts, rivets, washers, all standard specifications, AN standard, military standard, American standard. Built to government specifications that any contractor could meet, this standardization extended beyond the aircraft itself. Tools were standardized. A torque wrench calibrated for one P-51 worked on all of them. Jigs and fixtures were identical across maintenance units. Technical manuals were the same in England, Italy, and the Pacific. A mechanic trained at Keesler Field in Mississippi could work on a Mustang at Leiston Field in England without retraining. The knowledge transferred perfectly because the aircraft were identical. March 15th, 1944, Augsburg, Germany. Hauptmann Wilhelm Schroeder lands his Bf 109 after a mission. His aircraft has minor damage. A hydraulic leak. The mechanics inspect it. They need a seal. A simple rubber seal. It's on order, should arrive in 3 days, maybe 4. The aircraft is grounded. Schroeder walks to the operations room. He's frustrated but not surprised. This is how it works. You wait for parts. Always waiting. That same day, at Bodney Airfield in Norfolk, Lieutenant Joe Peterburs lands his P-51 with the same problem. Hydraulic leak. The crew chief identifies it immediately. A seal in the landing gear actuator. He walks to the parts depot, returns in 15 minutes, has the seal, standard part, fits all P-51s. The repair takes 45 minutes. Peterburg's aircraft flies the next morning's mission. No waiting, no delay. The war doesn't stop for a rubber seal. The German pilots start to notice something strange. The same American fighters keep appearing. Same tail numbers. Same nose art. They shoot them up. Watch them limp home. The next day, they're back. Fully repaired. How is this possible? Battle damage should take days to repair. Structural damage even longer. But the Americans keep flying, keep repairing, keep coming back. A captured Luftwaffe pilot, interrogated in April 1944, tries to explain what he's seen. They shoot our aircraft. We see them damaged. Smoke. Pieces falling off. They fly away. Next day, same aircraft, same numbers. Not possible. You cannot repair aircraft this fast. Not without magic. The interrogator doesn't say anything, just hands him photographs. Hard stands at American bases, mechanics working through the night, portable lights, welders, patch panels, spare engines on stands, mountains of parts in organized crates. This isn't magic, this is logistics. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Americans don't just repair aircraft quickly, they repair them while under pressure. April 8, 1944. The 8th Air Force launches over 1,000 bombers against targets across Germany. The fighter escort includes 300 P-51 Mustangs. They encounter heavy resistance. 63 German fighters shot down. But the escorts take losses too. 44 fighters damaged, 18 severely. They limp back to England. At Debden, the 12th Fighter Group's mechanics are already waiting. The damaged aircraft land between 1,400 and 1,600 hours. Battle damage varies. One has a 20mm hole through the fuselage. Another has a shredded aileron. A third took hits to the coolant system, the Merlin engine's vulnerable point. The crews don't panic. They don't convene meetings. They just start working. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The crew chiefs divide the work. Structural damage goes to the sheet metal specialists. Engine issues to the power plant mechanics. Control surfaces to the airframe team. They work through the night. Portable floodlights illuminate the hard stands. Welding sparks fly in the darkness. By 0600 hours the next morning, 37 of the 44 damaged aircraft are mission ready. 7 require additional work, but 37 are flying, less than 16 hours after landing with battle damage. Oberst Johannes Steinhoff, a Luftwaffe fighter commander with over 100 victories, is captured in April 1945. During interrogation, he's shown maintenance logs from American fighter groups. He studies them carefully. His face shows disbelief. "You're repairing fighters in hours?" he asks. Major structural repairs. The American intelligence officer nods. Steinhoff shakes his head. "We couldn't do this. Our mechanics are skilled, perhaps more skilled than yours individually. But your system, your parts, your organization, we had nothing like this. The system is the weapon. At Hill Field in Utah, workers maintain and overhaul Packard Merlin engines for P-51s. Engines arrive from Europe by ship, damaged, worn out, 500 hours of combat flying. The depot workers tear them down completely, inspect every component, replace worn parts, reassemble, test, return to service. The entire process takes weeks, but dozens of engines move through simultaneously. The pipeline never stops. Fresh engines constantly ship to Europe. The same system applies to airframes. At Burtonwood in England, The base air depot maintains a massive inventory of P-51 components, complete wings, tail sections, fuselages, engines, propellers, radios, guns, everything. An aircraft too damaged for field repair comes to Burtonwood. If the damage is extensive, they don't repair it. They rebuild it. Bolt a new wing on, install a fresh engine. The aircraft returns to combat as a hybrid. Original fuselage, new wing, different engine. It doesn't matter. Everything fits. Everything works. Standardization makes cannibalization effortless. May 8, 1944. An escort mission to Berlin goes badly for one P-51, flak over the target, multiple hits. The pilot, Lieutenant Robert Johnson, manages to fly at 300 miles back to England. He lands with one wing nearly torn off. The spar is cracked, the skin is shredded. Fuel is leaking. The aircraft is a write-off, or it would be, in any other air force. The crew chief at Leiston looks at the damage. He doesn't even try to repair the wing. He orders a replacement from the depot. It arrives by truck the next morning. A complete wing assembly. The old wing comes off, 8 bolts at the root, disconnect fuel lines, electrical connections, hydraulic lines, takes 4 hours with a crew of 6. The new wing goes on. Same 8 bolts, same connection points. Everything standard, everything interchangeable. Reconnect fuel. Electrical, hydraulics, test the systems. The aircraft flies again in 2 days. Total time, including waiting for the part, 48 hours. A similar repair in the Luftwaffe would take weeks, if the part was available, if the depot could manufacture it, if transportation existed, if the German supply system was breaking down. Allied bombing was destroying factories, rail lines were cut, road transport was attacked from the air. Parts that should take 3 days to arrive took 3 weeks, or never arrived at all. Aircraft sat grounded, waiting. Pilots sat idle. The math was simple and brutal. An aircraft on the ground contributes nothing. June 6, 1944. The invasion of Normandy. The 9th Air Force's fighter groups fly over 11,000 sorties in support of the landings. P-51s, P-47s, P-38s. They strafe, they bomb, they escort, they take losses, flak, ground fire, combat damage. By nightfall, over 100 fighters are damaged. The mechanics work through the night on both sides of the channel. Forward airfields are operational within hours of capture. Damaged aircraft are patched in the field, engines are swapped, wings are replaced. By dawn, most are flying again. The Luftwaffe launches 400 sorties on D-Day. 400. The Allies flew over 14,000. The disparity isn't just in numbers of aircraft, it's in sustainability. An Allied fighter damaged in the morning can fly again in the afternoon. A German fighter damaged in the morning might fly again next week. If ever, the Americans treat aircraft as expendable, not carelessly, but practically. If it's cheaper in time and effort to replace than repair, they replace. Parts are abundant, aircraft are abundant. The only scarce resource is time. July 1944. The 357th Fighter Group records their maintenance statistics. 96 P-51 Mustangs assigned, 89 mission capable on any given day, a readiness rate of over 90%. This is extraordinary. In any air force, aircraft break, systems fail, routine maintenance grounds some, battle damage grounds others. But the 357th keeps 90% flying. Every day, day after day, month after month. Compare this to the Luftwaffe. By July 1944, Germany has approximately 400 day fighters operationally available on the Western Front, but only about half are mission-ready on any given day. The rest are grounded. waiting for parts, waiting for repairs, waiting for fuel. The Americans have numerical superiority, but they also have availability superiority. More aircraft, more of them flying. It's overwhelming. Lieutenant Heinz Knoke, a German fighter pilot, writes in his diary in August 1944, "Today I watched an American Mustang make an emergency landing near our field. The pilot was unhurt. We examined the aircraft. Battle damage. The left wing was badly shot up. I asked our mechanics how long to repair such damage. They said at least a week. Probably 2. One of our men who speaks English talked to the American pilot. The pilot said his squadron would have it fixed in a day. We laughed. Propaganda, we thought. Impossible. 3 days later, a captured German patrol is brought through an American airfield. They're being transported to a POW camp. The trucks drive slowly through the flight line. The Germans see mechanics working on fighters, damaged fighters. One crew is replacing an engine, another is patching wing panels, a third is installing a new propeller. The work is fast, efficient, organized. Parts are everywhere, stacked in crates, labeled, organized by number. The Germans stop laughing. This isn't propaganda. This is reality. August 10th, 1944, a Luftwaffe intelligence report reaches Berlin. It details American maintenance capabilities based on prisoner interrogations and captured documents. The report estimates that American fighter groups can repair minor battle damage in 4 to 6 hours, major structural repairs in 24 to 48 hours, engine replacements in 12 to 16 hours. The report is met with skepticism. These numbers seem impossible, but they're not. They're conservative. The Americans are often faster. The secret isn't just standardization, it's training. American mechanics go through 4 months of technical school. They learn aircraft systems, engine theory, hydraulics, electrical systems, structures, but they don't learn one specific aircraft. They learn principles, standardized principles that apply to all aircraft. When they arrive at their units, they specialize. But the foundation is broad. A P-51 mechanic can work on a B-17 if needed. The systems are similar. The parts are standardized. The knowledge transfers. The Luftwaffe trains differently. German mechanics are specialists from the start. A Bf 109 mechanic knows the 109 intimately, but put him on a Focke-Wulf 190 and he struggles. The aircraft are too different. The parts aren't interchangeable. The systems vary. Specialization creates depth of knowledge but limits flexibility. The Americans prioritize breadth. It's less elegant, less artistic, but infinitely more practical. Flying constant missions. Aircraft are taking damage. The crews are exhausted. The solution would be impossible in the Luftwaffe. They borrow mechanics from a B-24 bomb group nearby, bomber mechanics. Men trained on 4-engine heavy bombers. They put them to work on single-engine fighters. Within 2 days, the borrowed mechanics are productive, not as fast as the specialists, but competent. The standardization makes this possible. AN fittings are AN fittings, whether on a fighter or a bomber. Tools are tools. Procedures are procedures. October 14, 1944, the largest Luftwaffe fighter reaction of the war. 750 German fighters attack American bomber formations near Magdeburg. The 353 fighter group shoots down 22. The 357 shoots down 30. But the critical number isn't the kills, it's what happens next. Both groups land with heavily damaged aircraft, bullet holes, cannon damage, some aircraft barely flyable. The mechanics work through the night. By morning, both groups are at 90% strength again, ready for the next mission. The Germans lost 200 aircraft in that battle, many pilots killed or captured. The loss is catastrophic, irreplaceable. A German maintenance officer is captured near Metz. Major Karl Bauer, formerly of Jagdgeschwader. He's an engineer by training. Educated at the Technical University of Munich. During interrogation, he's asked about German maintenance procedures. He describes them in detail: the careful inspections, the precision work, the hand-fitting of parts. The interrogator listens patiently, then asks, "How long does it take your mechanics to replace a damaged wing panel?" Bauer thinks. "Depends on the damage. Minor damage, perhaps 6 to 8 hours. Major damage, we might need to replace the entire panel. That would take 2 days, maybe 3, if we have the part. If not, we must fabricate it. That could take a week. We can do the same repair in 90 minutes. Bauer's face shows his disbelief. Impossible. The panel must be fitted precisely, aligned, riveted, sealed. This takes time. The interrogator shrugs. We use pre-formed panels, standard sizes, standard rivet patterns. We drill, rivet, seal. 90 minutes. Bauer is quiet for a long time. Finally, he speaks. We were told American fighters were inferior. Inferior design, inferior construction. Mass-produced garbage. But if you can repair them this fast, if you can keep them flying, does quality even matter? You overwhelm us with quantity, and your quantity is always available, always ready. Our quality sits on the ground, waiting for parts we don't have. December 16, 1944. The Battle of the Bulge begins. Germany's last major offensive in the West. The weather is terrible. Fog, snow, low clouds. The Allied air forces are grounded for days. The Germans advance. Then, on December 23rd, the weather clears. The sky fills with Allied aircraft, bombers, fighters, thousands of them. They pound German positions relentlessly. The Luftwaffe tries to respond. They manage a few hundred sorties. The Americans fly over 2,000 on that day alone. The German pilots are brave, skilled, desperate. But they're outnumbered 10 to 1, and when they damage an American fighter, it's back in the air within hours. When an American damages a German fighter, it stays grounded for days. If it ever flies again. The mathematics of attrition are brutal and one-sided. January 1st, 1945. Operation Bodenplatte. The Luftwaffe's last gasp. 900 German fighters launch a surprise attack on Allied airfields at dawn. They catch the Allies unprepared. Destroy over 400 aircraft on the ground. It's a tactical success, but strategically, it's suicide. The Germans lose 237 pilots. 59 of them are unit commanders, irreplaceable men. And the 400 Allied aircraft they destroyed? Replaced within a week. Fresh aircraft from depots. Damaged aircraft repaired. The loss barely registers. The American maintenance system absorbs the blow, like water absorbing a stone. There's a ripple, then nothing. By January 8th, the Allied fighter groups are back to full strength. The Germans lost a quarter of their remaining fighter pilot force. For them, there is no recovery, no replacement, no second chance. February 11, 1945. 3 months after his capture, Major Bauer is in a POW camp in Mississippi. He's being held with other Luftwaffe officers. They're treated well, fed adequately. The Geneva Convention is observed, but what haunts Bauer isn't his captivity. It's what he learned. He writes in a letter that will later be intercepted by censors. We lost this war in the maintenance hangars, not in the skies. We built beautiful aircraft. They built practical aircraft. We trained master mechanics. They trained adequate mechanics in vast numbers. We hand-fitted every part. They bolted on standardized parts. We were artists. They were factory workers. And the factory workers won, March 24, 1945, the last major Luftwaffe resistance. Over 100 German jets and conventional fighters attack Allied bomber formations. The P-51 escorts meet them. The jets are faster. The Me-262s can outrun anything the Allies have. But they're fragile. Their engines last 25 hours before overhaul. They require special fuel. Their pilots need extensive training. And when they're damaged, they're nearly impossible to repair in the field. They're technological marvels. But they're not practical, not sustainable, not enough. The Mustangs are slower, simpler. But there are hundreds of them. And when one gets damaged, it's repaired overnight. The Americans lose 8 fighters. All 8 are back in service within 3 days. The Germans lose 37 aircraft. None will fly again. The disparity is total. April 16, 1945. Leiston Airfield, Germany. The Luftwaffe's main test facility. American troops arrive. They find dozens of captured Allied aircraft, P-51s, P-47s, B-17s. All in various states of disassembly. German engineers were studying them, trying to understand how they were built, the ease of maintenance, the interchangeability, the standardization. One German engineer tells the American soldiers, "We couldn't believe how simple your aircraft were, how crude we thought. Then we realized, simple means reliable, crude means fixable. We built sophisticated machines, you built machines that win wars." May 8, 1945, VE Day. Germany surrenders. The war in Europe ends. The final tallies are staggering. The 8th Air Force alone flew over 1 million sorties. P-51 groups destroyed nearly 5,000 enemy aircraft in air combat, more than 4,000 on the ground. They lost about 2,500 Mustangs total, a ratio of nearly 4-to-1 in aerial combat. But the real ratio is in availability. For every German fighter that flew, 3 American fighters flew. For every hour a German aircraft was in the air, it spent 10 on the ground. For every German mechanic, there were 3 American mechanics with better parts, better tools, better systems. The P-51 Mustang wasn't the best fighter of World War II because it was the fastest. It wasn't. The Me-262 was faster. It wasn't because it was the most heavily armed. The P-47 had more guns. It wasn't because it was the most maneuverable. Several aircraft could turn tighter. The P-51 was the best because it combined enough of everything with one critical advantage. It could be maintained quickly, repaired easily, kept flying constantly. In a war of attrition, availability is everything. Franz Stigler, the Oberleutnant who waited 3 days for spark plugs back in March 1944, survived the war. He emigrated to Canada in 1953, became an engineer. Years later, he attended an air show where a restored P-51 was on display. He talked with the owner, a former USAAF mechanic. They discussed maintenance. Stigler described the German system, the precision, the craftsmanship. The mechanic listened politely, said, "We didn't have time for craftsmanship. We had a war to win." That was the difference. The Germans built aircraft to be perfect. The Americans built aircraft to be available. Perfect aircraft that sit on the ground contribute nothing. Available aircraft that fly every day win wars. It's not romantic. It's not elegant. The crews that kept them flying were mostly invisible. No medals, no recognition, no glory. Just cold nights on windswept hardstands, frozen fingers turning wrenches, welding sparks in the darkness, patching holes, replacing engines, reloading ammunition, refueling tanks, day after day, mission after mission, month after month. They worked while pilots slept. They worked while battles were fought. They worked while the war was won. Technical Sergeant James McKnight of the 353rd Fighter Group said it simply, decades later. The pilots got the medals. We got the planes in the air. Both mattered. But without us, there were no missions, no victories, no war won. We turned wrenches, while they turned the tide. 4 hours, not 4 days. That was the difference. That was how we won. The German pilots were excellent, brave, skilled, experienced. They shot down thousands of Allied aircraft, but they couldn't overcome mathematics. They couldn't overcome logistics. They couldn't overcome a system that turned 18-year-old farm boys into competent aircraft mechanics in 4 months. They couldn't overcome standardized parts that fit every aircraft. They couldn't overcome an industrial machine that treated fighters like consumables. Replaceable. Repairable. Inexhaustible. In the end, Germany lost the air war for many reasons: fuel shortages, pilot losses, strategic decisions, but one of the most fundamental was this. Their beautiful, handcrafted fighters sat on the ground, waiting for parts that never came, while crude, mass-produced American fighters flew mission after mission, repaired in hours, maintained by kids who learned the trade, in trade schools, kept flying by a system that valued availability over perfection. The Americans didn't win because they built better aircraft, they won because they could fix them faster. 4 hours, not 4 days. That was the secret. That was the weapon. That was victory. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.